Okay, so we left off learning that enzymes work by making chemical reactions happen easier, requiring less energy, like a tool, okay? Now, if you remember when we were talking about proteins, one thing that I said was that the shape of a protein determines its function. In other words, its shape has everything to do with the job it needs to do. And this in enzymes is very true since enzymes work like a lock and a key. This is the classic analogy. An enzyme works like a lock and a key. This means that each enzyme is specific to its substrates. Each enzyme only has specific substrates that can fit and bind to it. And then the enzyme can make that chemical reaction happen quicker once they bind, kind of like the nutcracker. It'd be like if you only had a specific nutcracker for almonds and a specific nutcracker for pecans and a specific nutcracker for hazelnuts. Enzymes work that way. They're very specific to their substrate. And since they're very specific, that shape is so important that if something happens to the enzyme to make it lose its shape, it won't work anymore. Kind of like if you melted the end of a key, it wouldn't fit the lock anymore. You wouldn't be able to open the door. So if we go back to the lock and key analogy, I have a key for my classroom. It won't start my car. It won't get me into my house. It's very specific to the lock that it can open. And if I melt that key, it won't work at all anymore, okay? If I change the shape of the key, it won't fit. So here's another diagram that I really want you to get to know. And they don't draw all proteins the same. This is another kind of cartoonish analogy of how it happens. So we're going to take a look at a couple of other pictures that are showing the same thing. So you can see that we always start, this is a chemical reaction. So we're starting with reactants. And in this case, since it's binding to an enzyme, since it needs an enzyme, it has a special name. It's called a substrate. So the substrate is the reactant. And see the shape of the reactant, the substrate? It fits perfectly to this enzyme. And the spot that that substrate fits perfectly into, like the lock and the key, this we call the active site. So there's a spot on the enzyme made specifically for that substrate, and only that substrate will fit, and if either one of these have the wrong shape, it won't work. So here this substrate fits perfectly into the active site on this enzyme, and when they bind together, we call this an enzyme substrate complex. So it's this big molecule now. And the way that they bind, the enzyme has the opportunity to make this chemical reaction, to break bonds and create new bonds way easier than if they tried to do it on their own. So when this happens, so once that substrate binds to the enzyme, it makes that chemical reaction easier. Remember, chemical reactions are just breaking bonds and recreating bonds. We're just taking the same chemicals and rearranging them. So once they've bound in here, it's much easier to break those bonds and create new bonds. And once those bonds are broken and remade and the chemical reaction is finished, then the enzyme releases the products. So we start with the substrate, the reactants. It binds to the enzyme changes it and releases the products. And in the process, the enzyme has not changed itself. The enzyme stays the same. Remember, just like the nutcracker, you can use it over and over and over. It's just a tool to make this chemical reaction happen faster and easier. Here's the thing though. Enzymes are very sensitive. And remember, if they lose their shape, they don't work. So they can, what we say, denature in the wrong conditions. And what it means to denature a protein is it loses its shape. So if you denature a protein, it loses its shape. Like an egg white is almost all protein. And when you cook it, it denatures. And once it's denatured, you can't put it back to its original state. And that's the way proteins are. That's the same with enzymes. That's the way all proteins are. And there are two ways to denature an enzyme. So one is temperature. We just talked about that. High heat. If you cook an egg white, you'll denature it. You change the shape of the protein, and you can't change it back. Another way is pH. You might not know this already, or maybe you do, but if you took an egg and you cracked it into a cup full of vinegar, eventually that vinegar would also solidify those proteins. It would denature the egg white the same way temperature would. It might not taste as good, but it would still denature those proteins. So temperature and pH are the two ways that you can denature a protein. So here's an example of how this would happen. Here we have an enzyme, and here's our substrate, and see, it's ready to fit right in that spot perfectly in the active site. Awesome, except we add heat. Now we heat up this enzyme, and look, the enzyme is denatured. It changes shape. Now the substrate no longer fits, and that's just basically what that's saying. The substrate cannot enter the binding site because it doesn't fit anymore. And so what we're left with is a useless protein, and the substrate was never changed. So once we denature a protein, it can't perform, it can't help those chemical reactions happen anymore. So here's another example. And the reason that I have these different pictures are because sometimes proteins are drawn differently by different textbooks or different tests. And if you remember, I don't know if you remember me saying this or not, but when we were talking about proteins, one thing that I said about proteins is that they're generally globular. So here's an example of a protein that looks globular. Here's our enzyme. Here's one of our substrates. Sometimes you have one substrate, sometimes you have more than one. Remember, there's different chemical reactions. Sometimes you're taking one reactant and breaking it into 2 or 3 pieces. Sometimes you're taking 2 substrates and building it into one, or sometimes, like in this one, you're just taking 2 substrates and just completely rearranging them into 2 different products. So we've got substrate A, substrate B. They both fit into their active site. That's the spot where they bind so that the enzyme can make it easier to break bonds and build bonds. Again, here would be, whoa, that's not what I wanted. Here would be our enzyme substrate complex, okay? There would be our enzyme substrate complex. Now, once the enzyme has this opportunity in this position, the enzyme can change those chemicals, break bonds, make new bonds, and what we end up with are 2 different products. So we started with something, we rearranged them using an enzyme, and you end up with something different in the end. And the enzyme is not changed. See, we have it unchanged. The enzyme is unchanged and can be used again. Here's one more picture. In this picture, just to save time, I'm going to explain that each one of these, if you remember, Proteins are made out of polypeptides. A true protein is more than one polypeptide. So we've got one polypeptide, a green polypeptide, a red polypeptide. Now together they all make a protein. And here would be the active site on this protein. However, if we introduce this protein to heat or acid or base, it denatures. And look at the shape now. Now there's no active site. Now it's changed shape and it no longer works. You're welcome to watch the raw foods diet from a vegan perspective. I'll put that on my website also. In the meantime, the next thing you need to do is make sure you turn in this worksheet. Now up here what we're looking at, look at this arrow is showing these two things going into the enzyme. Anything going into the chemical reaction, that makes these the reactants. It binds to the enzyme, so this is the enzyme substrate complex. It changes, see, we see it, still the enzyme substrate complex, but now it's changed those reactants, and it releases the products. In the meantime, here's our enzyme, unchanged, and right here, this spot right here is where those substrates can bind. And anytime the substrates can bind, that is the active site. So this is where they bind, that's where they fit, that's the active site. On this diagram below, what you needed to label were the reactants and products. So we start with the reactants, we end with the products. We start with the reactants, we end with the products. The difference between these two is that look at the size of the activation energy here. A lot of activation energy needed. That chemical reaction is not going to happen on its own. So this would be the activation energy, the normal activation energy. However, in this reaction, look at how little energy is needed. Now it's just a little mound. Now that chemical reaction can happen easier. So this would be the activation energy with an enzyme. And then you should be able to find the answers to the last 3 questions in your notes.